As we peer into the vast, infinite expanse of the universe, our curiosity is ignited by the countless enigmas that beckon from the darkness. Celestial body is an invisible force as weave a complex tapestry, beginning us to unravel their secrets. In the beginning, there was an infinitely density ball of matter which is started to expand and would eventually give rise to the atom. But no one knows exactly how big a space is. It is difficult to determine because of what we can see in our detectors. We measure long distance in a space in light years, representing the distance it takes for light to travel in a year. From the light that is visible in our telescope, we have charted galaxies reaching almost as far back as the Big Bang, which is thought to have started our universe about 30.8 billion years ago. This means we can see into a space to a distance of almost 30.8 billion light years. Roughly 95% of all the mass in the universe is made of what scientists have dubbed dark matter, but it's not known what it actually is, or if it is even matter by our current definition. However, while dark matter doesn't emit light or energy and cannot therefore be directly observed, what else could be enough to be dark matter? What else could be massive enough? One possibility was quickly ruled out. Dark matter could be made of atoms. Everything scientists can observe in the universe, from people to planets, is made of matter. Matter is defined as any substance that has mass occupies a space. But there is more to the universe than the matter we can see. Because of that, when you go to the space, it's just empty. Black. In one word, nothing. Most points in the space are so far from anything else that you can't even see the nearest galaxy. And that is for dark matter, something scientists have never seen it. We only assume it existed because without it the behavior of galaxies simply wouldn't make sense. But the question is that, does the cosmos go on forever?
There are something like 2 trillion galaxies. We haven't counted them all, but that's an estimate based on surveys of the local universe. 2 trillion, 2,000 billion galaxies. And each galaxy is, let's say, around the size of the Milky Way. Some are bigger, some are smaller, but the Milky Way has 400 billion stars in it. It takes light over 100,000 years to cross a galaxy.
Is an age-old question in philosophy. And what we know for certain is that the universe is bigger than we observe it. Essentially because the farthest edge of the universe we can see don't like the edge at all of the universe we can see. The observable universe is still huge, but of course it has the limit. But no one remembered the great scientists who had discovered the nature of time. But the astro engineers know that time was not the same across the cosmos. And here within the immense gravity of the black hole, time tricked more slowly. Black hole bend both space and time, and with this intense curvature comes intense gravitational pulls not even light able to escape. In the vicinity of a black hole, where gravitational fields or immense time become more and more curved as you get closer to the certain, compared to clock in the distant universe near the heart of the darkness, time ticks very slowly. The stranger gravitational field will have the same effect on you. So, what is the time? The question seems almost meaningless. From the beginning of the universe to the present day, time is one of few things we regard as a regular and unchanging. But that's a simple, albeit vague answer to an incredibly complex topic. Time is around us and is the basics of how we record life on Earth. Civilization rise and fall, stars are born and extinguished, and our method of tracking how those moments relate to the present remains unchanged. But time is not as constant or as simple as it may seem. Scientists once thought that space and time were spread, and that the universe was merely an assortment of cosmos. Space and time were spread, and that the universe was merely an assortment of cosmic bodies arranged in 3 dimensions. It's been more than a century since Einstein's relativity shocked our understanding of time and space. But how does it really work? And what does it really mean? His theory, which Einstein published in 1915, expanded the theory of special relativity that he had published 10 years earlier. Space and time are inextricably connected, but that theory didn't acknowledge the existence of gravity. According to the general relativity, the space-time is a 4-dimensional objective that has to obey an equation. The consequence of Einstein's vision of relativity were quickly uncovered the special theory, and whilst everyone felt time passing at 1 second per second, different clocks will tick off different amount of time. Now, how we define a unique notion of the past? Within the equation of relativity, all past, present, and future are already written. The entire history of all things is already out there. But when I studied physics and astronomy, the fact that really blew my mind, one that really made me rethink how I thought about the universe. When I learned that aliens are seeing the Earth from the past. Imagine if an alien was watching Earth from 23 light years away, the World Trade Center would only just be falling. An alien almost from 250 light years away would be watching the American Revolution in real time. And if they were 2,600 light years away, they would literally be watching the Cyrus, king of the Persian. Think about that. They're not watching a movie. This is happening right now.